Hello students, one of the important topic of double integration is changing the order of integration. We'll see how to do the change of order of integration for double integration and how to evaluate it. The first step for change of order of integration is we need to consider the given limits and sketch the region and shade it. Then we need to draw a strip parallel to x-axis horizontal strip or strip parallel to y-axis vertical strip. Then based upon the strip, we need to identify the new limits and then rewrite the given double integration as a changed order double integration. With an example, it will be clear for you. We need to evaluate this double integration by changing the order of integration. So very first step is we need to identify the given limits and sketch the region. So given limits are y is equal to x square, lower limit of the inner integral, which is a parabola. Upper limit of the integration, inner integral, is y equal to x, which is a straight line passing through the origin. So we need to draw a parabola, vertex at the origin, so this is the parabola, y equal to x square. Next we need to draw the straight line y equal to x, which is a straight line passing through the origin. Then take the outer integral limits. X varies from 0 to x equal to 1. X equal to 0 is y-axis, and before drawing the upper limit of the outer integral, we need to find what is the point of intersection of the straight line and the curve y equal to x. So the point of intersection is 1, 1. So we need to draw the straight line x is equal to 1 passing through this point. So the straight line is x is equal to 1. Then the region is the region bounded by all these four limits. So this portion is the region. So now we need to draw a strip parallel to x-axis to change the limits. So see here, we identified the region using the limits of the double integration given. So the region is this portion shaded by blue color here, and we need to change the order of integration. So we need to change the order as dx dy. So we should take strip parallel to x-axis. So a thick red color line is drawn here parallel to x-axis. So based upon that, we'll be identifying the new limits for the changed order. So lower end of the strip meets this line. Equation of this line is y equal to x. And upper end of the strip meeting the parabola, whose equation is y equal to x square. So from this, we can identify the limits for x and then for y. So new limits for x is equal to y, that is the lower limit, and upper end of the strip touching the parabola, so x is equal to root y. So these are the limits for x. You can see the entire region and write the limits for y. So y varies from 0 to y is equal to 1. Is it clear how to identify the limits for the changed order? Then we need to rewrite the given double integration has changed the double integration with change of order as dy dx. So after this it is changing the order of integration. Next we need to evaluate this double integration. So inner integration is with respect to x. Retain the outer integration as it is 0 to 1. Integrate this inner integration with respect to x. So if you integrate with respect to x, you will get x squared by 2. Limits are from y to root y. Retain this dy as it is. Then if you substitute the upper limit root y the whole square is y, minus lower limit is y, so y square whole into dy. Now we need to integrate this with respect to y. Retain this 1 by 2 as it is. Integrate with respect to y. Integration of y is y square by 2 minus integration of y square is y cube by 3. Limits are from 0 to 1. Substituting the limits, you will get 1 by 2 minus 1 by 3. Lower limit is 0, does not exist. So if you simplify this, you will get it as 1 by 6, which is the value of the integration. So like this, you can try these two examples. The first one, double integration whose lower limit is y equal to x square, which is a parabola, about y-axis, vertex at the origin, and y equal to 2x is a straight line. It is a straight line. So accordingly, you should draw the parabola and the straight line. Substitute x value, you will get what is y. Plot it and connect the points, you will get the straight line. Outer integral limits are from 0 to 2. So substituting, using these integral limits, you can identify the region. Then using the strip parallel to x-axis, you can identify the limits for x. You need to change this order as double integration dx dy. So you should take strip parallel to x-axis. Identify the new limits and try it. Similarly, you can try this third one also. Another example which is for region, dividing the region. So we'll take this example. We need to evaluate by changing the order of integration. So as a first step, we need to take the given limits. Inner integral, they are the limits for x. Inner integral, y variable is there. You need to fix these limits for x. Outer integral, you need to fix for y. Then you need to check the order. The order is in the correct form, dx dy. So inner integral lower limit is x is equal to y, which is a straight line passing through the origin. Upper limit is x is equal to 2 minus y, that is also a straight line. Then outer integral lower limit is y equal to 0, which is x-axis, to y is equal to 1, which is a line parallel to x-axis. Then we need to draw two straight lines. One straight line is passing through the origin, y equal to x-axis, y-axis. Another straight line gives some value for y, give value for y as 0, x is equal to 2. So y is 0, x is equal to 2 means 2 units here in x-axis. Then put x is equal to 0, you will get y is equal to 2 units. Here, join these 2 points and extend it. So this is a straight line, x is equal to 2 minus y. This straight line is x is equal to 2 minus y. This straight line is x is equal to y. Then now we need to draw y equal to 0 and y equal to 1. Y equal to 0 is x-axis, y is equal to 1. Before drawing that line, we need to find this point of intersection of these two straight lines. When x is equal to y, this is y is 1. Y is 1 means x is also 1. So point of intersection is 1, 1. Then you need to draw that straight line which passes through this point. And extend it. So this straight line is x is equal to 1. It should be y equal to 1, right? Sorry. So 1, 1 means we need to draw the straight line parallel to x-axis passing through this point. Like this. So it is y is equal to 1. Right. Next we need to shade the region. The region bounded in between these two straight lines. Other side bounded by y equal to 0 and y equal to 1. Now we need to change the order. We need to change the order as double integration dy dx. So I should take strip parallel to y-axis. So if I draw the strip parallel to y-axis, here this strip is touching x-axis lower limit, upper limit is touching the straight line x is equal to y, this straight line. And if I draw the same strip here, lower end is touching the x-axis, upper end is touching this straight line x is equal to 2 minus y. So there is a change in the upper limit. So we need to divide the region into two regions about the line x is equal to 1. So we need to divide the region into two portions, region 1 and region 2. After this point 1, 1, the change occurs. So we need to divide at this point. So the straight line equation is x is equal to 1. Accordingly, we need to write the limits for region 1 and region 2. So for region 1, I am taking the first portion as region 1. I am taking this as region 1 and this is region 2. So now we need to write limits for region 1 and region 2. So region 1, y limits are from y equal to 0 to y equal to x. And x limits are from 0 to x is equal to 1 up to the yellow color line, whose equation is x is equal to 1. For region 2, see the strip, lower end of the strip meeting x-axis. So lower limit is y equal to 0. X-axis whose equation is y equal to 0. Upper end of the green color line is touching the straight line x is equal to 2 minus y. So I can rewrite y as 2 minus x. And x limits are from 1 to, it starts from yellow line, 1 to 2. So like this we need to identify the limits for region 1 and region 2. And then we need to split and rewrite this double integration. So double integration 0 to 1 and y to 2 minus y. Y to 2 minus y. Integrand is xy. Integrand is xy. Order is dx dy. So we need to change the order for this given double integration. So the changed order is xy dy dx, and the limits for y varies from, and we splitted this as two double integrations, and accordingly you need to write the limits for both the integrations.